Welcome everyone to a first video tutorial on the usage of R, especially in the version of Rstudio. Therefore you should have downloaded Rstudio from the web. You can easily search for it on Google, just type in Rstudio, click the download button and off you go. It could be that you will need the normal version of R, therefore just visit the internet pages from CRAN or CRAN to download R for itself. So I'm starting here with the version 2.13, and as you can see here you have three parts of the screen. So you have the input window over here, so-called console or console. Then you have a workspace and history region over here, and something called files, plots, packages and help window over here. So maybe I think we should start with some basic arithmetic to give you a feeling about how R functions and how R behave in doing things. So first of all, you just type in something like x equals 2, which means that you have a variable x and it has a value of 2. As you can see here, now we have also this input in the history, so each step we are doing here in the console will be also shown in the history. So we will now do y is equal 4. There we go. And as you would suggest, you can easily type in x multiplies y, which gives you an answer of 8. But there's one special thing. Let's go back into the workspace here. So we have the values x and y, but there is no resulting variable. So what we can do now is we can type in z is the same as x multiplied with y, and now we have the value z, we have the variable z, which is filled with the result of the operation x multiplies y. So let's have a look in the console. What is the value of z? Just by pressing the name of the variable. So it will give you an answer of that is 8. Now let's go a little bit further, due to the fact that I hope my tutorials will cover a lot of statistics, and for statistics it's very important to get a feeling about vectors. So how to create a vector in R. Let's go on maybe with a vector of x. So as you can see, this is the same variable, and we will say x is a column-wise vector which has several entries. Let's start by 1, 2, 3 and 4. So now you can see the value of x has changed. It's a numeric vector. You can also type in a function. I'll go a little bit further now, like class, which gives you the class of the object x, and this is a numeric vector. So we have x, and now let's imagine you have a very long vector or a lot of data, and it is all stored in the variable x, like 1500 entries. Just by clicking x will give you all the information of the vector, but due to the nature of 1500 numbers in a row, you won't have any overview of your data. So you can also go here and double press on x, so you will get an information here. It's the edit function, and you can see you have all the entries listed here, and you can easily go to a special position, change the value to 5 maybe, click on save, and there was a function called which is called fix, and so we have fixed the variable x. Just by pressing x again and enter, we can see that the third position of the vector has changed. Let's go back again go to number 3. Oh no, that was wrong. Click on save, and we have fixed them again. Fixed it again. So what do you do? What would you think will happen if we will try to create a y vector with the quadrats? I don't know. Is it correct? With the with the squares of the number. That's the word. So just try it. X upper code 2. Oh, he doesn't know this one. So let's go further. X upper 2. So here we go. He's done an element-wise squaring of each element in the vector x. And we can also say y is the same as x up 2. We can go here and say, what is y? Y is the same as 1, 4, 9 and 16. So now we have created two vectors, x and y, and I would like to show you another possibility which is quite useful in some cases to create long vectors, which is called the sequence. So let's start again with the vector x. Let's say we would like to have all numbers up to 100, and as you can imagine, it's very complicated or very time consuming to type in 1, 2, 3, 4, 5, 6, 7, 8 and so on. So what we'll do now, we don't take the column function or column vector function, which is somehow used here. We will take the sequence function for doing that, and we will given a starting point and an ending point. So as you can see here, we have a starting point of 1 and point 100. Let's go back into it and say what is x, and as you can see here, these are the numbers 1 up to 100. Once again, type in y is the same as x upper 2. Come on, x upper 2, and there we go again. So let's say, or maybe you will has or you has consulted some books regarding R. You will see some possible other syntax as I'm using here. So especially for English, in English keyboard layout, it's often useful to use something like this. Y will get the element behind the equal sign. So in this case, x upper 2 up to 2, or x squared. So which is more or less the same, as you can see. So yeah, no, oh, that was a wrong one here. So it's not this one, it is this. So but let's take a look on this term. So I was typing in y is less or equal x squared, which is more or less true in every case, because x squared is the same as y in this case. So you can easily choose or use bitwise comparison operators like this one. So we can create, or we can use the z value and say, what is that lower than, or is that z lower than 2, which gives you a false number. Of course, the z is filled with a number of 8. So is z greater than 2? That's easily true. But yeah, what is if we will compare that z against x, which compares each element of both vectors against each other. So that is in these cases true, and in the other cases false. So we will just clear the screen, go to view, here edit, clear console, and we will start from the beginning. So what we have done now, we have created two vectors, x and y. We have seen some basic arithmetic, some basic Boolean operations, but let's be honest, why have you chosen R, or why have you chosen to learn R instead of learning SAS or Stata or also MATLAB? It's because of it's open source, and there are a lot of packages available in the internet for very special purposes. So we will go now here into detail on how to install a package. Just click install package, choose the name of the package, and press install. That's it. So I've chosen here some different packages at the moment, and you have to make sure to use it. You have to activate the special package. So, but what could be another purpose of using R and RStudio? Especially the guys who are thinking about thus will think, okay, maybe visualization, and to visualize some content in R is very, very easy. So let's go and say we would like to visualize the distribution of x against y, which should follow a very easy quadratic plot. So therefore we will plot some elements, and what shall we plot? Of course, x and y. So say x and y. As you can see here, you have the values of x plotted against the values of y. Let's zoom into the plot scene, and here we go. So very easy, very nice quadratic plot. Let's say we would like to add a line, and not each point as a circle. Once again, we can see here very common line which describes the distribution of x against y. So let's say you have some questions about the syntax. So of course this option here I'll looks afterwards very similar. So you just saying, okay, there's another option, and we will specify the style of the plot. So therefore you can choose help here and say we would like to have some help for plot. No occurrences found. Let's go into this one, say once again plot, and there you have the help for the plot file, a plot function, generic x against y function. So you can see here that is the basic syntax: plot x, y, point, etc. So arguments to be passed to the method, in this case plot. So here we go. What type of plot should be drawn? We were chosen lines here, but you can easily go maybe also with B, which is both. Let's go into the zoom. Okay, there's just circles around. Back again to the help for both lines and points. I don't know what was going wrong in this case. So, but there are also a lot of other arguments you can pass to the function plot, especially here x lab, y lab, and the y against x aspect ratio. So let's say, or let's go back to the plot. You can see here as you can see here, the ratio is not 1-to-1. So let's say plot xy ratio is the same as a vector 1 against 1. Okay, ratio is not a function parameter. Of course it is not. It is here called ASP. Go back again, say ASP is 1 against 1. Doesn't look that good. Let's play around a little bit. Say 10 against 1. Not that good as well. Say 1 against 10. We won't get any further. Say we will use a sequence against 1 to 100. Nah, not that good. Maybe we have to check once again the help function and see plot.window. So numeric giving the aspect ratio y against x, see details, ASP. So special K ASP is equals 1 produces plots where distances between points are represented accurately on screen. So we will go again, say plot is the same as or plot x against y, ASP is 1. Go again. So we will zoom in, and of course it is very easy that the quadratic function, if you are having same values on the x and y, is hard increasing. So let's go into plot, not an x in this case, but a sequence against 1 to 5, and now maybe we will go not too far. Let's make another variable x2, which is a sequence from 0 to 5 in steps of a half. So once again, x2, there are 11 numbers, and as you can see, we will start with 0, 0.5, 1, 1.5, and so on. So what have we done now? We have created another sequence, but we have chosen not to use the default distance between each element, but a distance of half. And we will go again, say y2 is the same as x2 squared, and say, so what I'm doing here is just pressing the upper and the lower button on your the cursors, so up and down, to go through my history to recall a function. Let's say this one, just adjust the variables, go again, and as you can see here we have the same plot as prior, but we will now create, that was wrong, and say this ASP is the same as 1, and now we will go again, same ratio, we will have the numbers of 1 up to 5 and the corresponding squared numbers. Let's go into the zoom. You can create your own view in here. So let's say make it very small in the x, and so you can see here that it's increasing as we have learned it in school. So let's go back into the possibilities. So we have used here ASP as an aspect ratio to adjust that, but we can also say there's an X-lab. But prior to this, I would like to show you how to create create strings. So x underscore lab is another variable, and it will be given the values of a string. Let's say x values. So you can see x underscore lab is the same as x values. Go again, y underscore lab is the same as y values. So here we are, x lab and y lab. And what we are doing now is we will recall the plot function and say x lab, or the label of the x axis, x is same as x underscore lab, and y lab is the same as y underscore lab. What we are having here now is, once again, the plot we have created prior, and there's a new label. You can easily create something like this as well, so just say x squared, and you can use, I think you can use LaTeX or tech scripting in your strings to create these beautiful plots. So we have x squared, x, and each point. So yeah, and maybe go with the type line, which looks far better. You can also create something like a plot with a title. Main is called the parameter, and say a function called squared. Again, there's the title, and you have it. And what is very good in Rstudio, as I think, is that you can easily save your images as plots or as PNG files. You can easily export it as a PDF. You don't have to call some special functions for that, so you can use that as well, but it's a built-in function, and this is beautiful. You can copy it to the clipboard as well, so there's no freaking around with some kind of plot functions or print functions especially. So what have we done here? We have created the plot, we have adjusted some options here, and you have to be aware of your options in each possible function you will use. But before the end of this session, I would like to show you a last thing. So let's go back to our very long vector, which was called x, and say we would like to have a special look into elements of x. So what we know until now is that we can type in x, press the enter button, and we will see that the 20th element of x is 20. Nice thing to know if this is a sequence, but how to call this one. Therefore, you will use these kind of brackets, and we just say call the 20th position in the vector of x. So you can also go like this: 20 up to 22. Which gives you the 20, 21st, 22nd element. It's easily to use also built-in functions, so you can create a cascade of functions. So we will go into the variable x, and the positions is controlled by the function sequence, and you will go like this, to up to 100 in steps of, now let's say 5, which is more easily 5 up to 100 in steps of 5, which shows you the 5th, the 10th, the 15th, 20th, and so on element. You can easily adjust this one, so you will just get the squared of these numbers. In this case, it's not very informative because of the structure of the vector x, but let's say you have some kind of random values, and especially by thinking on Excel, where you can easily locate a column or a row and say, okay, let's just take these elements and copy them maybe to another cell and so on. You can easily go by this just by pressing like z_2 is the same as x controlled by the sequence 2 4 0.5. So how was that able to function? Is there a second point fifth element? Let's have a look into z_2. There you go. So there was something like a default processing behind your call of the function. Keep that in mind by pressing functions, typing in functions, because there's often the argument in using open source, everything is open, so you can go into the function and you can see everything there. There are no black boxes around. As you can see here, this is some kind of failure, because he hasn't thrown you some kind of information like be careful or something like that. So you have just created a new vector z_2, and he has done this function for you by adjusting the values in the sequence. So the values in the sequence are 2, 2, 3, 3, and 4, and that's it. So keep that in mind by using R and also open source products as well, and ask yourself every time, what have I done, and was that correct? Especially if you would like to coordinate your steps and would like to create a script after that, which you can recall every time. Be sure to use comment. We can start a comment by pressing this symbol and say this is a symbol. And sorry for my desktop now, I had some issues with my notebook. So this is a symbol, and you can easily adjust your typing, like say x is the same as 2, and create a comment after that by pressing that symbol and say we put the value to x. So everything is ignored beyond that symbol. So that's for it for the moment. Thank you very much for watching, and yeah, we are not finished, I think. So one more thing I have to say: if you would like to store your history, do it. Just press here history and say save the history. It will be stored as an R history file, and you can also store your workspace. So as I've said, my PC crashed under Linux. You can store your values as a workspace as well, and in another session you can import that one more time. Thank you very much for watching. If you have any issues or comments, just drop a line in the comment section here on YouTube. Otherwise, just write me an email if you have any suggestions for next tutorials in R, and hope to see you again. Thank you very much.